Today's lesson, we're going to finally get into some probability stuff here. So the learning target would be that you can use combinations and permutations that we've talked about previously in order to find probability of doing something. All right, before we get into some of those problems, though, let's talk about what probability is. We say the probability of a successful outcome would be the number of successful outcomes over the total possible outcomes. So we're going to divide, and then when you divide, you're going to get some decimal number that could be made into a fraction or changed into a percentage. And when you do that, your probability is always going to be somewhere between 0% and 100%. You can't go over 100 or be under 0% when doing it. It's going to be somewhere in between those two numbers, including 100 or 0. You could have 0% chance of something happening, or you could have a sure thing where you know it's going to happen 100% of the time. The closer a probability is to 0 means that the outcome is less likely to occur. The closer your probability is to 100%, that means the more likely it is to occur. So anything in between, you can kind of judge by that. If it's right in the middle at 50, then you got an equal shot of it happening or not happening. All right, so now that you know a little bit about probability, if you have any friends like this, you know that they're probably wrong. This guy says, I'm 101% sure I know more about probability than you. Probably not true there. All right, so let's look at number 1 here. It says a bag contains 4 blue, 3 green, and 6 red marbles. They want us to answer now some questions about that. So part A says, suppose you reach into the bag, draw 1 marble, find the probability that the 1 marble was green. So here a successful outcome is being green, and we know there's 3 of those successful outcomes. This is going to be over the total number of outcomes. So to figure out the total, we need to then total up all the marbles in this bag. So we got 4 plus 3 plus 6, that's a total of 13. So the probability here would be 3 out of 13 would be your probability. Now you can leave your probability like that as a fraction. Other times they may have you change to like a decimal or fraction. So if you divide this 3 over 13, it'd be the same as about 0.23, or if we change that to in terms of percentage times by 100, that would also be the same as about 23.1% chance of this happening. So you can always list your answer either as a fraction or as a decimal percentage. All right. For B, it says suppose you reach into the bag again and draw 1 marble. Find the probability that the 1 marble is not red. Okay. So if we had put that green marble back, we're back to our 13 total marbles. They wanted us to find what's the probability it's not red. Well, not red would mean it's either going to be green or blue here. So if we know there is a total of 7 of those, it would be 7 out of 13. Or again, you can change this to a percentage. If you divide that out, it's pretty close to about 53.8%. So either of those 2 answers is good. All right, so those ones that's pretty simple probability. We'll come back to that, but we're going to look at how do you do some harder ones here today where you have more possibilities of things happening. So on this next one, number 2, it says what's the probability of selecting 2 vowels from the word algebra? Okay, so we got this word algebra. We want to find out how many successful outcomes over how many possible. Here, a success is having vowels. So we got to figure out how many vowels are in this word algebra. There's 1, 2, 3 vowels. Okay, so we got to figure out what's the number of ways we could choose 2 of those 3 vowels. So if we randomly were picking, how many ways can we choose 2 out of 3 things? Well, we don't really care which order we select them, just that we select 2. So what we're going to use here is a combination. Combination we use when we don't really care about the order, but we want to know how many ways of doing it. There are 3 vowels here, and we're selecting 2 because that's what they told us in the problem was we want to be selecting 2. Okay, now we got to also though figure out how many total possible outcomes there are going to be. So how many total letters are in this word algebra? Well, let's count them up. 1, 2, 3, 4, 5, 6, 7. So total, there's 7 in there. We still need to know how many different ways there would be of choosing just 2 out of 7 things. So again, we don't really care the order, but we need to know how many total ways can we draw 2 letters out of this group of 7 things. So to find this probability, we're going to have to figure out what are both of these equal to. We looked at how to do these on your calculator and the formula. Calculator is probably easier, so if you hit 3, find your combination in your probability menu. And 2, there are 3 different ways we could choose 2 vowels in this word. One way would be selecting these 2, another way would be selecting these 2, and a third way would be selecting the first and last one. Okay, over how many ways can you select 2 letters, any 2 letters out of these 7 letters? So again, we got to use a combination here. 7 combination 2. There is 21 different ways of selecting just any 2 letters. So our probability here is 3 out of 21, which is the same as 1 out of 7. There's a 1 out of 7 chance, or if you divide that out, it's about 14.3% chance of randomly choosing 2 letters and 2 of them being vowels. So when you got more than one thing, when you're choosing more than one thing, combinations is one way of going through and figuring that out. All right, let's look at number 3. Part A says Julie has a collection of 32 albums on her iPad. 18 of them are R&B, 14 of them are rap. As she is leaving for her trip, she randomly chooses 6 albums to make a new playlist. What is the probability she selects 3 R&B and 3 rap? Okay, so what we want to know is what is this probability? If you see the word probability, we're going to have to divide, again, our number of successes out of our total. So what we need to figure out is how many ways can she randomly select the 3 R&B and 3 rap. It doesn't matter what order, just that we're selecting those ones. So this is another combination since we're selecting more than one. Okay, now let's start with R&B. We want us to select 3 R&B albums. What we need to know is how many total R&B albums are there that we're selecting these 3 from. So if we go back, it looks like there's 18 to choose from. So we got 18, choose 3. Okay, but we also need to choose 3 rap. Okay, so 3 rap albums. And it says there's 14 total of those. So we need to figure out both these number of possibilities. How many possible ways of choosing the R&B? How many possible ways of choosing the 3 rap? And remember, with possibilities, you always want to multiply those together to find the total possibilities. So that's the top of our probability fraction. On the bottom, we need to figure out the total. How many total ways of doing this? Well, total, there are 32 albums. How many are we selecting out of those? We're selecting a total of 6 albums. And so we want to find out how many possible ways of just choosing 6 out of any of the 32 albums. And if we find this out, this should tell us the probability of what we're looking for. One thing to keep in mind as you're doing these problems, especially on these where you're choosing different groups out of different things, the things you're choosing on top need to be the same as the things you're choosing on bottom. So we're choosing 6 total things on bottom. If we're choosing 3 and 3, that's the same as 6. So this should work out if we calculate it out correctly. So now what you need to do is go into your calculator, figure out what are these going to equal, and then see what you get. If we do this 18 combination 3, that's going to give you 816. If you do the 18 or 14 choose 3, that's going to come out to be 364. And if you do the bottom one, 32 choose 6, that's a bigger number here. It's 906,192. Now you should be able to put this in your calculator and figure it out. So let's multiply this here. If you multiply those two numbers on top, you get this. Okay, and this is then our answer. Now, if you have to, like, say this is an ACT question or something, and you have to answer in fraction form, that probably won't be one of the multiple choice options for you. So you want to simplify this fraction if possible and check to see what's the simplified fraction. So if we enter this number in, okay, that's no number on top here, and enter a number on bottom, and divide them, it'll tell you that this is about 32 point, pretty close to like 32.8%. Okay, and if you need to answer with a percentage or decimal, then you'd have those. But what is this as a simplified fraction? How you can do that again on your calculator is to hit math, select your fraction button, and then hit enter, and it should give it to you as a simplified fraction. So if you had to answer with a simplified fraction, it would be 884 over 2,697. So that would be the simplified fraction probability. That would be the percentage. These two are saying the same thing. All right, let's try part B and see what you get there. So in part B, now they want to know if Julie has now selected 6 albums, of which 3 R&B, and they're the Mary J. Blige, the Michael Jackson, Aretha Franklin, and 3 rap, Dr. Dre, Eminem, and 50 Cent. If she randomly selects an album to be played, and each album is equally likely to be selected, what is the probability that she will play Michael Jackson R&B album and Eminem rap album as her first 2 albums? Okay, now we're starting to get into something different here. Now the order that we're doing these is important. So if order is important, remember back to what you talked about with permutation and combination. If order is important, then we want to choose permutations. So this is now a permutation problem rather than a combination problem. So just like we talked about before, when we're doing this, now we're just down to these 6 albums. On bottom, the total number of ways you can order 6 albums would be 6 albums arranging all 6. Or that would be also the same as just 6 factorial. On top, we got to figure out what would be the chances that the first she will play Michael Jackson R&B album and Eminem as the first 2 albums. So just the first 2 albums, the probability there is 2, select 2. We want to make sure that those 2 have to come up first. So that would be 2 and 2 times, now we got these 4 other ones. They don't really tell us which order those are going to be, just that those are the other 4 albums. So what's the probability then that those 4 come up as the other 4? How many different ways can you order the last 4 albums? So we want to figure out what this is going to be. So use your calculator again. We talked about how to do permutations too. Those ones, like the first one here, if you hit 2, go to your probability menu, and you can select permutation and hit 2 again. The number of ways of having Eminem and Michael Jackson come up as the first 2 would be 2. Either Michael Jackson's first and Eminem's second, or Eminem's first and Michael Jackson's second. Okay, times, if you do permutation of 4, pick all 4, you get 24 ways of doing that. Over the bottom way of 6, arranging all 6, that would be 720. So this comes out to be 48 out of 720. If you reduce that, that comes out to be 4 out of 35 chance that Michael Jackson or Eminem come up as the first 2. That's also the same as about 11.4%. So one of those two. So when order is important or you're arranging something, remember use permutations over combinations. All right, let's take a look at number 4. On this one, it says a board game is played with tiles with letters on one side. There are 56 tiles with consonants and 42 tiles with vowels. Each player must choose 7 of the tiles at the beginning of the game. What's the probability a player selects 4 consonants and 3 vowels? I want you to try this one out on your own right now. Why don't you pause it, see if you can set this one up and solve, and we'll see what you get. All right, let's see what you had. We want to select 4 consonants and 3 vowels. So let's start with the consonants. We don't really care the order, just like say we're playing Scrabble here. We don't really care the order we're picking these, just that we end up with 4 of them. And they told us that there's 56 total, so combination on this one. With the 3 vowels, we're choosing 3 of them. They told us there's 42 total. We want to multiply these together to find the total possibilities of our successful ways of doing this over now the total. And the total that we're drawing here is 4 and 3. So we're choosing 7 total tiles out of the total number of tiles in the whole game. The total number of the tiles in the whole game would be 56 plus 42. So there would be 98 total tiles. So if you set it up like this, you were dead on. So now you just got to solve that out. Find both of those combinations, multiply them together, and divide. And it comes up to be kind of bigger numbers here. You should get like, I think, this many total possible ways of doing the stuff on top. Quite a big number. Over the bottom one is like 13 billion something. So a lot of different ways of arranging this many tiles. And if you divide that out, it's about a 30.5% chance that happens. So that's about your percentage. So when you start dealing with more things, you oftentimes get way bigger numbers. Okay, let's look at the next one. Number 5 says, for this next semester, Lisa has signed up for English, pre-calc, Spanish, geography, chemistry. If class schedules are assigned randomly and each is equally likely to be at any time of the day, what's the probability that Alyssa's first 2 classes in the morning will be pre-calc and chemistry in either order? Okay, so now we're talking about classes. Okay, we are again arranging these classes. This is going to be a permutation problem. So we want to make sure that the first 2 are pre-calc and chemistry. So if they're going to be arranged in that would be 2 arranging 2. But she still has 3 other classes the rest of the day. So we got to figure out how many ways to arrange those last 3 classes over how many just different schedules could she have? How many ways to arrange her schedule? That would be 5 classes arranging all 5 of them. So this one, if you solve this out, 2 pick 2 is going to be 2. 3 picking 3, that would be 6 different ways to do that of arranging those last ones, and then arranging all 5 would be 120. So we end up getting 12 over 120. That simplifies to 1 out of 10. There's a 1 out of 10 chance her schedule has calc and chemistry in some order at the beginning. That's also the same as 10%. That would be a good schedule in the morning, calc and chemistry. All right. Let's flip to the back here. On the back, we talk about a couple other things here. Theoretical probability and experimental probability. Theoretical probability is what we've been doing so far. If you figure out what should happen, that's kind of what we've been doing. So if you were flipping a coin 10 times, theoretically, we know you got a 50% chance of each thing happening. You should get 5 heads and 5 tails. Now, experimental probability would be actually doing it and figuring out what happened. So let's say you were actually flipping a coin. You could flip, and if you flipped it 10 times, it could have landed on head 7 and tails. There's a little mistake here. 3 times. That could happen. does that mean that there's something wrong with the coin? No, it's just that theoretically it should happen half the time. Will it? Not necessarily, but as you keep flipping, the theoretical probability should start to kind of even out if you kept flipping more. So for number 6, they want us to answer, is this a theoretical problem or is this a experimental probability? So let's read it. It says, if a hand of 4 cards is dealt from a standard deck of cards, what's the probability all 4 cards are hearts? Is this theoretical or experimental? Well, they didn't actually do this yet. And so if they haven't actually done it, it's always going to be theoretical. If they had actually done this a bunch of times and had some results, then it would be experimental. So this is theoretical, and they do want us to solve this out. So let's see if we can figure it out. What's the probability all 4 cards are hearts? We don't care about the order, just that they're hearts. So this is combination. We're dealing 4 cards. How many of them are hearts? Well, if you remember back from what we talked about with cards, there's 52 cards and there's 4 suits. So there's 13 of each suit. So we got 13 hearts in the deck. Over how many just different ways could we get 4 cards out of the deck out of 52 cards? So our probability would be whatever this comes out to be. If you do the first one, the top one, you get 715 ways of getting 4 hearts, and just the different ways of getting 4 cards out of the deck is 270,725 ways. So if you divide that, you got 11 out of 4,165 would be the probability, or that's about 0.26%. Not very likely to happen that if you just randomly deal 4 cards, that they all 4 come up hearts. All right, let's look at another one of these. Number 7 says, if 2 dice are rolled, what is the probability you will roll a sum of 5? Is this theoretical or experimental? Well, did they give us any results of, did it come up heads or I'm sorry, what the totals were? Nope. So it's not going to be experimental unless you've already had some results come from it. This is another theoretical one. Okay, what would this probability be? Well, if you're rolling 2 dice, you got 6 possible outcomes on one dice. You got 6 possible outcomes on another dice. So there's going to be 36 total possibilities. So on the bottom, we got 36 different outcomes that could happen. How many have a sum of 5? Well, this one you might want to organize it somehow. If we draw out all the different possibilities here, here's those 36 different things that could happen right here. How many of them add up to 5? Well, a 4 and a 1, a 2 and a 3. If we flip it around so that the other dice has the 2, the other dice has the 3, and again, flipping around 4 and 1, there's 4 of the 36 outcomes that have a sum of 5. So this would be 4 out of 36, or that's the same out of a 1 out of 9 chance that this happens. All right, the last thing we're going to talk about, odds. Odds are another way of stating the likelihood of an event. Suppose the odds against winning a contest are 5 to 2. Okay, this means that for every 5 chances of losing, there are 2 chances of winning. So when you do odds, you look for your favorable outcomes compared to your unfavorable outcomes. Notice that total is not part of this. Okay, there is no total involved. You don't find the total when you do odds. You look for what are you looking for, and then the other things that are not going to be favorable. So odds in favor, if they ask that, that's the number of favorable over the number of unfavorable. Odds against an event are the number of unfavorable compared to the number of favorable. Okay, so let's look at some odds problems here. And number 8, okay, it says in some skating competitions, the orders in which the competitors perform is determined by random drawing. Suppose the competition involves 5 skaters with 5 different names. Find the probability the skaters will perform in alphabetical order. Okay, so here they said probability. So we want to do a probability problem here. What's the chances that they're in alphabetical order? Well, if these 5 people have 5 different names, there's going to be one of those orders that has them in alphabetical order. How many different ways, though, can we order 5 people? Well, if we're ordering 5 people, that's an arrangement. If we're arranging, we know that that's a permutation. So this one is going to be a permutation of 5, arranging all 5. That's also the same. Anytime you arrange all the things, that would also be the same as 5 factorial. Those two are equivalent to each other, because it'd be 5 times 4 times 3 times 2 times 1. And if you put that in your calculator, that means we got a 1 out of 120 chance of this happening. Okay, let's do number 2. B says find the odds in favor of 5 skaters performing in alphabetical order. Now notice this problem says odds, not probability. So what's the odds that in favor of 5 skaters performing in alphabetical order? Well, we know there's, again, one way that this can work. Okay, but here we don't want to put 120. That's the total. What we want to put is what's the other different possibilities that could happen? Well, it would be all the possibilities, all the different ways you can arrange except alphabetical order. So if we take our 120 ways that they could come out minus the 1 in alphabetical order, that leaves us with 119. So the odds would be 1 to 119. Okay, C. What's the odds against the 5 skaters performing in alphabetical order? Again, it's an odds question, but this one is against. So that would mean we're looking for what's the number of ways they're not going to be in alphabetical order? 119 to the alphabetical order, which would be 1. So it's just changing the order of that odds. All right, D. What's the probability? Notice it says probability that the skaters will not perform in alphabetical order. Okay, well, this would be not performing in alphabetical order would be 119 ways over the total, which we know is 120. So that would be the answer there. And E, suppose that the probability of an event is 24%. What's the odds in favor of that event? And then it says also against that event. So let's start with the fact that we are doing an odds problem. Okay, let's look for in favor first. If we're talking about in favor, 24%. Well, we know percentages are always out of 100% here. So if our odds of being in favor, if it's out of 100%, means that if we take 100 minus 24, that the percentage that it doesn't happen would be 76%. So the odds in favor here would be 24% that it does happen compared to 76% that it doesn't happen. So those would be the odds in favor. Now, generally, if you're doing this, and it's like if it'd be a question on the ACT, that again wouldn't probably be one of your options. You want to reduce this. So if we reduce this down, 4 is a number that goes into both of these. 4 goes into 24 6 times. It goes into 76 19 times. So that would be the odds in favor. The odds against this happening then would be the reverse. It'd be 76% chance it doesn't happen to 24% chance that it does happen. And again, if you reduce that, that'd be 19 to 6. So odds don't use totals. They use what you're looking for to what is the other possibilities. Okay, try some of the practice ones out now and see how you do.